You know what let's do today? Let's go ahead and do some modeling with M&Ms. Specifically what we're going to model is selection mechanisms. This refers to the way that populations change in evolution. Now there are lots of situations in which you'll find selection mechanisms at work in nature, but in this example we'll use some squirrels because everyone knows that squirrels come in yellow, green, and blue. In this particular example of mechanisms, we have really two different colors on two opposite ends of the spectrum. We have one extreme, and that's yellow. And then we have sort of a blend between the two, and that's our average green. And then we also, on the other end, have the extreme of blue.
What's happening?
But all is not well in the land of the squirrels. In order to have selection, you have to have selection pressures. And in this case, we have some predators around.
Uh-oh. Look out!
And let's assume that our predator hunts by sight.
Here it comes! Run away!
So let's imagine our environment. Our environment has a background color, in this case blue. And here's our population of squirrels. Now notice how easy it is for our predators to spot the yellow squirrels and the green squirrels.
Goodbye, cruel world!
But the blue squirrels are a lot harder to spot, and so they have a better chance at survival and reproduction.
Alright.
Now as evolutionary time goes by, and we observe this population, we might notice that the phenotype frequencies, the percentages of the different colors, begin to change, and they change pretty drastically. Now we can actually graph this pretty easily. Over here on the left, we can record the frequency, or the percentage, of each different color. And we can place each color on the bottom, and these are called phenotypes. So we have our extreme number 1, our average, and our extreme number 2, laid out on a spectrum. Now in this example, the population that we started with had roughly equal frequencies of yellow, green, and blue, so this was our original population, this dotted line. But as we observed selection taking place, we noticed that the yellow and green squirrels decreased and the blue ones increased. And so our selected population kind of looks like this. It's pushed over to the side, and so we call this directional selection. Let's go ahead and start summarizing. Now let's look at another scenario. In this case, our background is green, and you can see that the yellow squirrels are pretty easy to spot, and actually so are the blue ones.
I will have my revenge!
Now we notice that the green ones kind of blend in, so they're actually more likely to survive and reproduce.
Fine by me.
So again, if we watch this population change over time, we're going to see some changes. But those changes are going to look different than the other scenario. Now we started with pretty much the same population as the first scenario, but in this case, the average, the color in the middle, is going to increase in frequency, but the extremes on the ends are going to decrease. And so our new population is going to have this sort of bell curve distribution. Because the average is selected, we call this stabilizing selection. So let's look at a totally different situation. Let's imagine a mottled background, sort of this checkerboard pattern. Now you might wonder at first, well, what's going to happen in this case? And it looks as though the green squirrels are actually the easiest to see in this case, so they're going to get picked off. But both the blue and the yellow can blend in, and therefore be more likely to survive and reproduce.
Awesome, way to go! Go us!
So ultimately what we observe is a decrease in the number of green squirrels and an increase in our extremes. So if we graph this in the same way that we have before, we see a decrease in the average and an increase in our yellow and blue phenotypes. And so we end up with this sort of valley-shaped selected population. And we call this disruptive selection. So let's think of everything that we've observed here and try to come up with a sort of generalization about what determines the mechanism of selection. The environment must be involved. We know this because when we changed the environment, it changed the selection mechanism. Now we only looked at 3 different environments. We looked at blue, green, and modeled blue and yellow, but we could have thrown yellow in as a background as well. And we observed that the environment influenced the frequency of phenotypes in the selected population, and that the phenotype best suited to its environment increased in frequency, which is exactly what natural selection predicts.